Oh, I love this one. I really do. This is good. This is good. This is a great learning opportunity. You might hate it, but it's a good one. Okay, it says a long branch circuit has been installed underground in Schedule 40 PVC. The circuit extends from a 277 480 volt three-phase 4-wire panel board to the load. The branch circuit conductors are connected to a 60 amp circuit breaker in the panel. The current that will be drawn by the load is 52 amps, and you would have run a number 6 gauge wire had the load been closer. However, due to voltage drop configurations, you will pull a 1/0. Okay, the smallest EGC that can be installed in the PVC is blank gauge or KC mill. Okay, this is a proportion question. How this works and what the basis are, or fundamental idea of it is right out of 250 122 under increased in size right here in the middle, 250 122B. It says if ungrounded conductors are increased in size for any reason, and a lot of times it's voltage drop, other than is required in 310.15B or C. Those are your adjustment factors for temperature. Wire type equipment grounding conductors, if installed, shall be increased in size proportionally to the increase in circular mill area of the ungrounded conductors. Okay, so we need to proportionally increase the EGC. So what this requires here is setting up a proportion. Okay, so it looks something like this. Originally, we had a number 6. Okay, and then we had a ground that was going to go with that number 6. But instead, I went ahead and put in a 1/0. Okay, and I'm just going to put equals here so I can write this all out. Now, I'm talking about a 60 amp circuit breaker. Okay, so a 60 amp circuit breaker would normally be number 10 copper. Okay, that would have normally been the ground. Number 10. Okay, so with the blank spaces that I have inside of this proportion, I'm going to go get the circular mills of these various conductors. Let's go get them. A number 6, a number 10, and a number 1/0. And I'm going to locate those inside of Chapter 9, Table 8, Conductor Properties. Okay, so let's start with that number 10. It is 10,380 circular mills. I'm going to write that in. 10,380. Okay, now I'm going to find that number 6. Let's find it. 26,240. Love these ones. 26. I don't know why, but I do like them. 26,240. Now, I'm going to find the size of that 1/0 that I had to increase, right? That 1/0 is 105,600 circular mills. 105,600. Cool. I've got my numbers for my proportion. Now what I'm going to do is cross multiply and divide. So I will take this corner down here and I will multiply it by this corner up here. So I'm just going to use the circular mill values, and we will do it thusly. I will take that 10,380 and I am going to multiply it by 105,600, and it's going to come out with an obnoxiously large number, 1,096,128,000. Woo! Don't worry too much about it though. Just leave it in your calculator, okay? Because we are going to divide by this corner. Okay, cross multiplied. Now we will divide by that opposite corner. So we will divide by 26,240. 26,240. I'm going to hit equal, and it's going to give me a much more manageable number at 41,700. 41,773. Now that I have that number, I'm going to go back to Chapter 9 Table 8, or maybe my book's still open to it, and I'm going to find me a conductor that is at least 41,773 circular mills. Number 4 almost made it. It was close, but it's not quite there. We're going to need that number 3 at 52,620 circular mills. Okay, so that is a number 3. Oh yeah. Okay, that's your proportion rule. That's how the proportion rule works in a scenario like this. It's a little bit tricky. It's a little bit long-winded. That's kind of fun, right? Right? Okay.